Welcome back to our channel. Today we are going to find the problem number 8. So what is this problem number 8, or how to find the solution for this is find the Z parameters for the circuit shown below. This is the network given to us. So let us try to solve it by two methods. I will solve it by my own method, which is nothing but method 1, and we'll try to solve it by one more method. Whatever the method you feel comfortable, you can use. And here I am using some conversion technique. So let's try to identify this network. So the voltage at this node is some V1, and what we need to find out is actually we need to find out Z11, and we have to find out Z12, and we have to find out Z21, and we need to find out Z22. So in order to find out these equations, we have the mathematical background that we'll discuss later. So now let's try to understand this network. So this is V1, and voltage at this point is also V2, and 0 volts, 0 volts, 0 volts. Okay, so the voltage at this point is 0 volts. Okay, so here to overcome the confusion, let's try to mark this as some node 1, and already it is marked as a node 2, and this is 0. Now let's try to see this in a clear fashion. So this is 1, this is 2, and this is 0, and here you are going to have one resistor. Between 1 and 0 you have one more resistor. Between 2 and 0 you have one more resistor. So this is 3 ohms, this is 5 ohm, this is 2 ohm. So this seems to be like an star. Now we are converting, we are using the transformation which is called as a delta to star conversion. So if you are watching this video for the first time, you can go to the channel and you can see how to convert a delta network into an star network. Okay, so now I'm going to convert this delta into an star. So the star I'm indicating with an black color line to what I'm indicating here. This is nothing but neutral, and this is nothing but the one more neutral, and this is nothing but the one more resistor. So this black color resistors we need to find out. What is given to us is an delta connected system. So how to find this resistor is this black resistor we need to find out. This black resistor is connected between 2 and 3 elements. That's why this resistor is 2 into 3 divided by 2 plus 3 plus 5. 2 plus 3 plus 5. Okay, so now similarly we need to find out this resistor. So this black resistor is connected between 3 and 5. So 3 into 5 divided by 3 plus 5 plus 2, and this resistor we need to find out. This black resistor is connected between 2 and 5. 2 into 5 divided by 2 plus 5 plus 3. So when you are trying to solve it, this is 6 divided by 10. This is nothing but 0.6 ohm. This is 5 3 is 15 divided by 10, which is 1.5 ohm. This is 10 divided by 10, which is 1 ohm. Carefully see this modification, which is makes the network more simplified. Now I am using this method 1 of solving. So therefore between 1, 2 and 0, the network is modified as shown here. This is the black color one, this is the another branch, and this is the another branch. So now this branch, what is this value of this resistor, which is 0.6 ohms. What is this branch value? 1.5 ohm. What is this bottom value, which is 1 ohm? Okay, so that's how we have been obtained, but basically this is linked with the remaining network. So between one we have some voltage source with a resistance value of 1 ohm. So this is nothing but V1, and here it is connected. Okay, so this is nothing but V1, and current flowing is I1. And now between 2 and 0 you have one more voltage source. This is nothing but the voltage source. If you use some 2 to 3 colors only, then you can understand better. That's why this is nothing but our neutral. Okay, now successfully I transform into my required format, and you can see here the current in this branch is flowing in this direction. Now when you see here, the current I1 flows across 1, and once again it flows across 0.5, and I can say that the current I1 is same. I can say that this 1 and 0.6 are connected in series connection. I'm going to reconstruct the circuit again as shown below. This is a voltage source, and here you are going to have a one resistor, and here you are going to have one more resistor, and here you are going to have the another resistor connected to the voltage source, which is nothing but V2. The value of this resistor is 1.5 ohm. This is V1. The value of this resistor is, these two are connected in series, 1 plus 0.6, this is 1.6 ohm, and here you are going to have 1 ohm. So the voltage at this point is plus V1, 0 volts, 0 volts, 0 volts. This is nothing but plus V2. Now, already I told the current which is flowing in this branch is I1, the current flowing in this branch is I2. So therefore, when you apply, I don't know the current which is flowing in this branch, let us try to mark this current as Ix. So to get this Ix, try to apply Kirchhoff's current law at the node. Okay, so what are the entering and leaving currents? I1 current is, you can see here, I1 is entering as well as I2 is also entering. I1 is entering as well as I2 is entering and leaving as Ix. Therefore, this value of Ix is nothing but sum of I1 and I2. So now let's try to apply KVL in this loop. Okay, so try to apply the KVL to this loop. Okay, so current is entering, this is positive, this is negative, and current in this branch, it is entering, this is positive, this is negative. The current flowing in this branch. Okay, now let's try to write down for first loop or first port. Apply Kirchhoff's voltage law at loop 1 or at input port side. Okay, so now when you apply this law, you can see here current is leaving, what is the polarity of the voltage, plus V1, and current is leaving, what is the polarity of the voltage, minus drop is I1 current into 1.6 ohm resistor, and the current is flowing, what is the resultant current flowing, minus I1 plus I2 into, what is the resistor value, this is nothing but 1 equal to 0. Again, now try to apply Kirchhoff's voltage law at the loop 2. In this loop, if you take, the current is leaving, or the leaving polarity of the voltage, this is plus V2, and current is entering at positive and it is leaving, or the leaving magnitude, minus current is I2, the resistance is 1.5 ohm, and coming to this branch, the current is I1 plus I2, the leaving polarity is minus, which is nothing but I1 plus I2 into 1 is equal to 0. Now what happens here is, let's try to express in the standard format. So V1 is equal to I1 into 1.6 plus I1 plus I2. So here V2 is equal to I2 into 1.5 plus I1 plus I2. So here let's try to bring in terms of standard format. V1 is equal to I1 into 1 plus 1.6, which is 2.6 plus I2, and V2 is equal to, what is the term here, we have I1 here and we need to take I2 as common. Now I2 is common, so this is 1.5 plus 1, which is nothing but 2.5. Okay, so now we have to express this in an standard format. Okay, so when you come to this procedure, we have the formula of writing the standard equation v1 v2 is equal to z11 z12 z21 z22 into i1 i2. So the original equation of v1 is equal to i1 into z11 plus z12 i2. Next equation is v2 is equal to z21 i1 plus z22 i2. So when you compare this equation, the value of z11 is 1.6. Here the value of z21 is 1, and the value of z12 is 1, and the value of z22 is 2. So now I'm writing all this in an z11 is 2.6 ohm, z12 is 1 ohm, z21 is also 1 ohm, z22 is 2.5 ohm. So these are the required answers. Okay, so this is how we obtain the z parameters for the circuit when we are transforming the delta to star, and I'm writing the delta in black color, and I'm applying the KVL at input loop and output loop. Now the same problem, let's try to solve in one more method. You can understand which method is more simplified for you. Okay, so this is the my method of solving the problem. So you have conventional textbook method also. How to find out? Let us try to observe here. Okay. So the second method is, so this is method 1. No worries, system is working a little bit slowly, no issue. So method 2. Okay, so let us try to do it again. So due to some technical issues, it is happening like this. So we have the second method of solving. So method 2, what we are going to do is we are writing the standard equations. Okay, so now what are the standard equations we have is, already I have written the equations here. So these are the standard equations. v1 is equal to i1 z11 plus z12 i2 is one equation, and second equation is v2 is equal to z21 i1 plus z22 i2. So here we are using the basics of the network. So what we are going to do is we are considering this output port current is 0. So I2 is 0 here, and once again I2 is 0 here. Whenever I2 is 0, then you can get Z11 as well as Z21. So Z11 is equal to V1 divided by I1, we are going to first find out, and Z21 is equal to V2 by I1. So these two now we are going to find out. So when you take this network into consideration, let us try to see how to solve this network. Okay. So now let us try to see here as per the given problem. we need to find out Z11. Okay, so V1 is applied here and a current of I1 is flowing here. So we are going to make output port as 0. So this port will not be there. This current I2 will become 0. Whenever I2 becomes 0, you can see here the network is reduced like this. Okay, so this is nothing but V1. So this is V1. Here it is 1 ohm. Here it is 2 ohm. Here it is 3 ohm. Here it is 5 ohm. And whenever the current in this branch becomes 0, okay, so current becomes 0, the voltage at this point will be shifted to this point. So therefore, the voltage at this point is once again V2. So this is how we got the network, and the total current flowing in this branch is I1. We need to find out V1 by I1. So you can see here the current I1 flows and the current gets divided across this branch, and current gets divided across these two elements, where these two elements are connected in series connection. When you look at this, you are going to get the network. You are going to have V1 and a 1 ohm resistor. So if you have any doubt, let's try to mark. This is 0 volts, 0 volts, 0th node, and this has some node 1. Okay, at node 1, and this is 0. So the element connected is only 2 ohm. And you can see here these 3 and 5 are connected in series connection. Whenever they are connected in series connection, I can say it is a sum. It is nothing but 3 plus 5 is nothing but 8 ohm. Okay, so the current entering the branch is I1. This gets divided. Now this branch and this branch are connected in parallel. So whenever they are connected in parallel, so it is very easy to solve. So the network will be like this. Okay, so this is an 1 ohm, and you are having an one more parallel branch. This is V1, this is I1, this is 1. So this is nothing but 2 into 8, product of resistance divided by sum of resistors. So product of resistors, 2s are 16 divided by 10, which is 1.6 ohm. This is 1.6 and this is 1. So the resultantly you can write down the magnitude of I1 is, so I1. So what is this I1? What is the voltage at this point? V1. So I1 is equal to current. What is the current flowing in this branch? I1 minus, sorry, what is the current flowing in this branch? V1 minus high potential minus low potential divided by what are the resistors connected in series? This is 1 plus 1.6, which is nothing but 2.6 ohm. But we require V1 by I1. So I am transforming this in that form. So V1 by I1. So V1 by I1, we are going to get the resistor as 2.6 ohm. So this is the value of Z11. So this is the step 1 of solving by second method. Now let's try to solve it by method 2. So second step you need to find out is V2 by I1. So this is what we need to find out. So how to find out V2 by I1 is very simple to understand. So we require V2 by I1 ratio. This is V2 and this is I1 ratio. Okay, so I want to link these two parameters. Okay, so now I'm redrawing the network for more clarity. So this is 1 ohm, this is 2 ohm, this is 3 ohm, and this is an 5 ohm resistor. The voltage at this point is V2 0 volts. The voltage at this point is V1 0 volts. Okay, and this is of some 3 ohm. So now I want to link V2 as well as I1. How to link is very important question. So I am assuming a current of I3 is flowing in this branch. Okay, the current I3 is flowing in this branch. So how to write down I3? So I can write down I3 with respect to node V2. So with this node I am writing I3. Okay, if you write down with this node it is different, but I am writing with respect to this node. Why? Because it is having V2. So I3 I can write down it as V2 minus 0 divided by 5. But here the problem is we had got V2, that's okay, but I3 we don't want, but we require I1. So we need to express I3 in terms of I1. How to do? So in order to do this, I'm going to express these two by using I want the current in this branch. I'm going to find out current division rule. Okay, so if you are new to this class, go and visit my previous old basic class, how to apply the current division rule. So now I can apply the current division rule only when the two branches are in parallel. This is one branch and this is another branch, where these two branches are in parallel. This branch and this branch are connected in parallel. Okay, so we can apply the current division rule. So I want the current I3. So current I3 I can write down it as, so this current I3 I'm going to write down. So how to write down the current I3? Total current. The formula for this current is total current into opposite branch resistor connected in parallel divided by the sum of R's connected in parallel. Okay. So sum of R's which are connected in parallel. So now I3 I can write down as, how to write down I3? What is the total current? The total branch current is I1. So this is the branch I am fighting I3. What is the branch in parallel to I3? This is the branch. What is the value of that resistor? Into 2 ohms divided by the sum of resistors which are connected in parallel. This is one branch, this is another branch. These two branches are in parallel. So therefore you are going to get 2 plus 3 plus 5. So that is equal to V2 by 5. So when you compare this, we require the expression for V2 by I1. So when you write down this expression V2 by I1, so this we can write down it as I1 into 2, I1 into 2 divided by, so this is nothing but 10, which is nothing but V2 by 5. So 5 ones are 5 5s are 5 will get cancelled. Therefore V2 by I1 is equal to 1 ohm. So this is how we are getting. So now we can see here, this is the value of Z21. Z21 is 1 ohm, Z11 is 2.6. Let's try to verify. Okay, so with the previous values what we have been obtained. Okay, so already we solved this problem by previous method. We already got Z11 is how much? Okay, so Z11 is 1.6 ohm and Z21 is 1 ohm. Okay, so Z21 is 1 ohm. So these two are correct. So now this next procedure we are going to employ to find out these two parameters by using the same method. So let us try to take this network again. So this is the network what we have in our hand. So now we need to find out the basic equations. So V1, V2, the same method we are going to apply. V1, V2 is equal to Z11, Z12, Z21, Z22. If you are very talented, you can apply of your own and you can verify with the answer. So those who are learners or those who want to learn newly, you can follow my class, which will make the same method we are going to follow. Okay. So here we have the equations as V1 is equal to Z11 I1 plus Z12 I2 is one equation. The next equation is V2 is equal to Z21 I1 plus Z22 I2. So in this equation previously we performed output port as open circuited. Now we are going to perform input port is open circuited, that is nothing but I1 is equal to 0. So this I1 will become 0. So whenever I1 becomes 0, let us try to solve the problem. So when I1 is 0, automatically you are going to get Z12. Z12 is equal to V1 by I2. So when I1 is 0, then you are going to find out Z22. So Z22 is equal to V2 by I2. We need to find these two ratios. How to find? Let's try to see from this problem. Now I am going to redraw the network. So now the current in this branch, okay. So let's try to redraw. It's not getting dragged off. So I'm going to redraw the network. So here we have V1, and here we have one branch, and here we have another branch. This is 2 ohm, and we have another branch and another branch, and excited with V2. So these values are 1 ohm, 2 ohm, 3 ohm, as well as 5 ohm. So now what we are going to do here is, we are making I1 as 0. The current in this branch, we are going to make it as 0. Whenever you are making the current as 0, so current is 0. What is the voltage created? So voltage V is equal to I into R. It's nothing but 0 into 1, voltage is 0. Open voltage is 0 means indirectly the current is 0, indirectly this acts like an short circuit. Therefore, the network is transformed as like this. So V1 is there, this is shorted, and we are going to have a 2 ohm, and here you are going to have a 3 ohm, and here you are going to have an 5 ohm. 2 ohm, 3 ohm, 5 ohm, and here you are going to have an voltage of V2. Now, whenever it is shorted, what is the voltage at this point? V1. What is the voltage at this point? 0. Automatically, this will be shifted here. This node will act as V1 and 0 volts. And now let's try to do what we actually require. So we require V2 by I2, which is called output driving point impedance. So how to do it? Okay, you can see here the current will come to this junction point, will flow across this branch, and also will flow across this branch. I can see these two branches are connected in parallel. So therefore, whenever they are connected in parallel, if you have any doubt, let's try to mark this node as 0 and this node as 0 volts. So now between 1 and 0, we are going to do it. Between 1 and 0, we are having one voltage source, and we are having one 5 ohm resistor. This is a 5 ohm resistor, and these are the two resistors. These two are already connected in. You can see here these two are connected in which connection? Series connection. Whenever they are connected in series, this is nothing but sum of resistors. 3 plus 2 is 5 ohm. Okay, so and you can see here again the current I2 is flowing, and the current will flow across this resistor and this resistor. Again, these two are connected in parallel. So whenever they are connected in parallel, you will get one resistor, and the voltage applied is nothing but V2, and the current which is driving it is I2. So product of resistance 5 into 5 divided by 5 plus 5 is nothing but 25 divided by 10, which is nothing but half of that rest value, which is nothing but 2.5 ohm. So I require the current I2. So how to write down this current I2? So current I2 flowing from V2 to 0. Okay, so current I2 equal to V2, my high potential minus low potential, divided by 2.5. So from here I want the ratio of V2 by I2. So therefore V2, this will come to the denominator, V2 by I2 is equal to 2.5 ohm. So which is Z22, this is 2.5 ohm. So now for this same network we are going to find out V1 by I2. Okay, so now I am redrawing the network. So now we are going to, from this network we are going to find out. So there's no need of voltage source, directly you can take from here. So you are having this branch and this branch and this branch. This is of 5 ohm, this is of 3 ohm, this is of 2 ohm, this is V1, and here we are exciting with V2 and current drawn is I2. Now when you observe here, we require a relationship between these two parameters, between I1 and V2. So between I1, I2 and V1. So in order to do it, what I am going to do here is, so we require relation between I1 and V2. So I am marking this an unknown current as some I4. So current I4 is equal to, how to write down the current I4? The current I4 flows across 2 ohm as well as flows across 3 ohm. So but I am writing I4 in terms of only V1. You may ask, sir, why you are writing like that? Okay, so this is very simple to understand why I am writing like this is, so I require relationship between V1 and I2. If I write down here, I can't write, I don't know the voltage. So here the voltage is clearly known, which is nothing but I1. So I1 I can write down it as, in terms of I4 is, I4 is the current flowing only in this branch with respect to V1. So I4 is equal to V1 minus 0 by 2. But so successfully we got a V1, but we require I2. But here what is there? I4 is there. We want to express I4, I4 in terms of I2. What to do now? So how to express this in this format is, try to apply current division rule to find the current in the branch I4. So if you are new to the class, you can go to my previous basic videos of how to apply current division rule. It will be there here. So now I will teach you how to apply the current division rule. Applying current division rule is, so this is nothing but the formula is total current into opposite branch resistor which is connected in parallel, divided by the sum of resistors which are connected in parallel. So what is the total current? How to write down I4 now is, this I4 I can write down as, what is the total current of the network, which is nothing but I2 multiplied with opposite parallel resistor. This is like I want the current in this branch. What is the branch in parallel? So this is one branch and this is one branch. I can say these two branches are once again connected in parallel. So whenever these two are connected in parallel, I am finding the current in this branch. What is the branch in parallel to this 2 ohm, which is nothing but 5 ohm. So write down that 5 ohm divided by the sum of resistors which are connected in parallel. What are the resistors connected in parallel? So first branch is 5 ohm. The next branch is 3 plus 2 again. 3 plus 2, that is equal to V1 by 2. So this I can expand and I can write down as I2 into 5 divided by 10, that is equal to V1 by 2. 5 ones are 5 twos are 2, 2 will get cancelled. I require the ratio of V1 by I2. V1 by I2 is nothing but what? 1 ohm. So this is the value of Z12 and this is the value of Z22 by using the second method. This is also a good method but time taking process. What I have showed is a very simple method, but you need to convert the delta to star. Now let's try to verify the values of Z22 and Z12 with the already obtained values. You see here Z22 is how much now? 2.5. So Z22 is 2.5, Z11 is 1 ohm. So that's how we successfully, so Z22 is 2.5, Z12 is 1 ohm. So that's how we have been find those values of as like this procedure. So both if you write down in an form, this is Z11, Z12, Z22 and Z11. Already in that method is very clear. So in this method if you write down Z11 is 2.6 ohm, Z21 is 1 ohm, and when you see here Z22 is 2.5, Z22 is 2.5 ohm, Z12 is 1 ohm, Z12 is 1 ohm. We can compare these two values. Okay, so we can easily compare these two values. We can see here almost all the answers are same. Okay, so method 1 and method 2, this is we solved it by method 2, this is we solved it by method 1. Okay, so but here we employed the conversion, which is nothing but the first method of conversion we have been employed. So whatever it may be, so successfully we have been find the parameters of the given network. Okay, so we have been successfully find the z parameters of the given network as it is. Okay, so these are the resultant values what we are going to get. Resultant values. So ultimate both the same or equal. So directly seeing this video, I don't say that you will get the subject. So you have to write down the question and practice of your own. And if you feel the content is really useful to you, please give a like. Please share with your friends. And if you have any doubts, let me know in comment section whether first method is simple or second method is simple. Give me in your comment section. And if you're watching for the first time, subscribe my channel with the name KV Tulasi. Yours obediently, Ram. Will meet in the next video. Thank you for watching.